Solving trigonometric equations when we're given domain constraints. So here we have a trigonometric equation to solve. Example, solve sine of theta equals -1/2, where theta has to be between 0 and 2 pi. And so we have learned about inverse trigonometric functions. And so given that, let's check to see, should we use an inverse here? Would that be convenient? So kind of our question before we get out of the gate is just, should we use an inverse here? And an inverse, we know, is the input is some sine value and the output is an angle. And here we're trying to find an angle, so this might be useful. So let's think about that. What about sine inverse of -1/2? That's going to give me some angle. Let's see what angle that is. Well, on the unit circle, we know that sine inverse can only have outputs between -π/2 and π/2. And sine has an output of -1/2 at the angle. This angle here is -π/6. So this is -π/6 is the output for sine inverse of -1/2. Now I notice that -π/6 is not in between this 0 and 2 pi like I need it to be. So here the inverse, I would argue, is not super helpful. I could still use that and kind of work with it, but it's a little bit kind of more of a pain, I think, to use the inverse here than like another tool that we would have would be like the unit circle, where we're just going to go solve directly. So what we're going to do is kind of put our sine inverse on ice or on hold over here and just use it when we can't use the unit circle. So we're going to save inverses for when the unit circle can't help us, okay? All right, so I'll just write that. I'll say save this inverse sine for when the unit circle can't help us, because that's going to be kind of our first pick. So how would we do that? Well, this is saying solve sine of theta equals -1/2. We know that means find the angles that make this statement true. So where does sine have an output of -1/2? Well, when I have this type of equation where it says solve where theta is in between 0 and 2 pi, I know that's just one nice revolution of the unit circle. And so in that case, that's really going to help me. So I'm going to draw my unit circle out here and then go, okay, I know on the unit circle that sine is the y value. So where is the y value? -1/2. That's down here, okay? So at these 2 points. And where are those points? Well, in quadrant 3 and quadrant 4. So what angles would those be? Okay, well, to here, this is maybe a little bit off, but this angle here is 7 pi/6. And then this angle here is 11 pi/6 to start in standard position and get all the way around there. So those are the only two angles within 0 to 2 pi. I know that's one period of sine where sine of theta equals -1/2. So here I'm okay to just write theta equals 7 pi/6 or theta equals 11 pi/6. So that or tells us that either one of these values will make this equation true. And now I want to write a solution set. So if you're not familiar with a solution set, right, it's kind of curly brackets. And in this case, I don't have any kind of like fancy solution where it's going to go on and on or something kind of funny. So I can just list them. So 7 pi/6, 11 pi/6 like that. And I can just list them in those curly brackets. And then I'm done. So if it tells you to give it in a solution set, and write it like that. All right, so let's keep going. Solve tangent of theta equal 1, where again, theta is still within 0 to pi. So first I'm going to try to use the unit circle if I can. So I'm going to draw out my unit circle and I'm going to think, where is tangent equal to 1? Well, our quotient identity tells me that tangent of theta is sine of theta over cosine of theta. And so if I want this to be 1, then that is where sine of theta and cosine theta are the same. They have to match. Well, I know that they are exactly the same along the line y equals x. Okay, and those two angles are going to be at pi/4 and 5 pi/4. In this case, this has two solutions. So I'm just going to write it like this. Theta is pi/4 or theta equals 5 pi over 4. And then the solution set becomes pi over 4 or 5 pi over 4. Okay. All right, this one, it's getting maybe a little more interesting. We still have that domain constraint, and again, I'm going to try to use the unit circle. So first thing I'm going to do is I say, this is 3 times secant squared of theta minus 4 equals 0. So this big secant squared theta thing, I'm going to try to isolate that before I isolate theta. So I'll start by just adding 4 to both sides. Right, so just imagine that was like an x. If you had 3x minus 4 equals 0, you would add 4 to both sides to get started. Your next step would be divide both sides by 3 to keep going, right? So it's the same thing here, and this 3 is just knock off, so the secant squared theta is kind of like undone here. Now, if I have something where I have secant squared of theta, I'm going to be careful here because I don't really like solving things in terms of secant, right? I know my unit circle really well for, say, like sine and cosine. So I'm going to write this in terms of cosine. This is 1 over cosine squared theta equals 4/3. And then I go, wait a minute, that's just 4 cosine squared theta equals 3, or cosine squared theta is 3/4. And I think that makes sense, right? We have secant squared is 4 over 3, and cosine squared is 3 over 4. They're reciprocals. Okay. Let's clear this old example out of the way. So we're ready to go. I'm going to keep going here in a new column, and I'm going to take the square root of both sides. So cosine of theta is plus or minus the square root of that whole thing. So square root of 3/4. Now I have to keep the plus or minus there because I don't have any information about the angle theta. So I don't want to limit it to either plus or minus. I want to keep them both. Now I need to simplify this. So I want to see if this looks like one of my unit circle values that I'm familiar with. I get plus or minus root 3 over 2. And that is definitely something that I recognize. So now I want to go to my unit circle and go, where does that happen? Well, let's think about where the pluses happen. The pluses happen right here at kind of those small angles because they have to go out the farthest to get that cosine value. And then the negatives are just going to happen kind of right behind there. And so I get actually 4 angles. 1, 2, 3, 4. And again, it's just saying do this only in between 0 and 2 pi. So I just need 4 angles there. This is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so careful here, what did I have? I have cosine of theta. I want to just, when I'm solving an equation, I kind of want something on the left and the right at both times. Okay, so, or all times. So cosine of theta equals plus or minus root 3 over 2. That's going to give me theta is pi over 6, theta is 5 pi over 6, theta is 7 pi over 6, and theta is 11 pi over 6. So what would my solution set look like? You don't have to put them in order, but if they're already in order, that's nice. Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, and then I'm done.